Hi, everyone. Good morning, good afternoon, good evening. Thank you so much for joining us today. My name is Christina Galan, and I'll be the moderator of this session, Maximize Your Energy Storage Assets with Auto Bidding. It's a pleasure to have everyone here from Zoom and also from YouTube. Thank you so much for joining. Today we have with us Jason Gran from Wartsila. Thank you so much, Jason, for joining us today. I'm going to do a couple of quick housekeeping rules, and then we'll move on to the presentation and the structure of that presentation. So this session will be recorded. It will be available for you in the following days. If you have any questions you may have for those on Zoom, please use the box of questions so Jason and I can see them and it's easier access. And then you have the chat for any other things. Let us know where you're from, your job, what you do, what's interesting, why you're interested in auto bidding. And also from Zoom, you can also use the chat. This session will be around 45 minutes approximately. Jason has a great presentation prepared for us. Then we will move to Q&A. We have a couple of pre-submitted questions, but also feel free to write those questions in. And if you have any questions, you have me and also Andres from our Ata Insights team available if you need any assistance. So I'm going to stop sharing my screen right now. So Jason, good morning for you. Thank you so much for joining us. The floor is yours. So if you would like to do a quick presentation, a quick introduction, and then a presentation, we will move on to your presentation and then we'll move on to the Q&A. So thank you so much for joining us.
Okay, thank you for the introduction and welcome everyone. Let me share my screen and we will get started. Okay, does it look okay, Christina?
Perfect.
All right, awesome. Yeah, once again, thanks everyone for joining. We're going to talk about auto bidding, specifically some of the work that we're doing at Wartsila in this space. Just real quick, once again, my name is Jason Gran. I'm a principal data scientist at Wartsila, specifically in the energy storage and optimization part of the business. Just really quick, I wanted to throw in a picture of one of our beautiful island projects. This is the island of Roatan in the Caribbean. You can see some of our battery storage containers there at the top. That's our grid solve container and a little bit of a view of the island and a beautiful PV array that we have there. So really quick, for those who aren't familiar with Wartsila or just need a refresher, I'm going to give just a quick background on what we do, some of the different things that we won't talk about today in detail. So Wartsila is one of the biggest players in the energy storage space. We have over 100 projects across the globe, many different countries. Right now, a little bit more than 5 gigawatt hours of storage, either in operation today or soon to be in operation. And we have a lot of different customers. Some of them are listed here at the bottom for projects that we've completed recently. Just a quick intro on some of the energy storage solutions that we offer at Wartsila. The first one is the GEMS digital energy platform, and we'll touch on that a bit today, talking about auto bidding. But basically, we have a power plant controller. So if you have a site with storage hardware, we offer a power plant controller software suite that has sort of local power plant controller functionality and fleet or sort of in the cloud level control for all of the sort of remote operation, maintenance, things like that. We sell a hardware product that can be used for, let's say, a standalone storage operation. Like a very simple, let's say, frequency response use case, or more complicated things with a mixture of different assets, and our software can be deployed and leveraged to control and optimize those different use cases. And we've been in operation with this sort of suite of software for more than 10 years, 14 years, almost 15. So it's a very mature, well-tested platform. In the middle here, you can see a picture of some grid solve quantums. So this is our battery containerized solution. They're modular. You can hook several of them together depending on the necessary storage and layout of a site. It's comes with a full long-term service agreement, different options as far as like warranty, lifecycle management, and it's been well tested and deployed in many locations. So that's just a really big, quick background on some of the other things that Wartsila does. I want to move to talk a little bit more about the topic at hand, which is auto bidding, automated bidding, sort of software-based, bidding, bid generation software. There's a lot of different names for it. But just I want to talk at a high level, sort of what are some of the main advantages of using automated bidding software? What are some of the techniques used in general? And then I'm going to dive a little bit more deeply into what we do with our product in this space called Intellibitter. So some of the main advantages are in electricity markets, there's a lot of sources of uncertainty that make it difficult to make a plan and stick to it throughout a trading day. So for example, let's say you have a PV plus storage site and you have uncertainty that comes in from the solar forecast. You may think it's going to be very sunny in the morning and I'm going to charge my battery. And then it turns out to be a little bit cloudy, and that has a chain of effects that kind of change the rest of your plan. So when these types of things happen, you have to be able to react quickly in a way that it looks forward and sort of takes those uncertainties into account. So that's one area where a software system can really help, either in place of let's say a human decision, or sort of augmenting some decision-making process. So that's one sort of major advantage of a system like this. Another one is similar in nature, but more about changes in market dynamics over a longer period, or things that aren't weather uncertainties or a load forecast uncertainty or something like that, but more about changes in market dynamics due to policy changes, or let's say as there become more and more renewable assets on the grid, more and more storage available, right? So those things change the strategies that might be optimal for your site. And having a system that can continually learn and adapt to those changes is really useful. The third one I'll mention here is just removing human bias from decisions. So this is one thing that AI, machine learning in general is very useful for, where if you have some decision you need to make, as a human, I may have some preconceived notions about what to do, or I may have some bias due to a high pressure situation, things like that, and I might make a decision that's not truly supported by the data. So using an automated bid generation system can help remove some of those sources of bias and lead to sort of less risky, overall performance. I want to talk quickly about some of the general areas of an auto bidding system that have to do with AI or machine learning, and sort of what are some of the approaches that are taken in this space. One of them is of course predicting the future. So if I want to know what bids I should submit into an electricity market, one thing I need to have is a view of what I expect to happen in the near term. So let's say I have, I need to produce some day ahead bid, a bid for charging or discharging a battery a full day ahead or something like that. Some of the uncertainties there are things like the price, the weather, right? I need to have some outlook on what those things may be at various points in the upcoming day or maybe tomorrow, in order to accurately, make a well-informed decision. So predicting the future is one of the key areas where machine learning comes into play. So estimating, let's say, price or weather, other things, let's say like a load forecast, things that feed into a price forecast and so on. So predicting those is useful. Predicting just the, a central value of those is one thing, but in an ideal situation, you can estimate the uncertainty as well. So I have just a sort of a picture here of, let's say, a price prediction over time, and it has some central value, but also has some uncertainty associated with that. Understanding how uncertain an estimate is really important, because you may want to take some probabilistic view of what I should do given the chance of something happening or not happening. Another thing with predicting, let's say, a price forecast is a lot of times differences between two price forecasts is important. Let's say I have a real-time market and a day-ahead market. Predicting when there might be a large difference between them could provide an opportunity for some sort of arbitrage. Or, I may want to reduce my commitment in some day-ahead market through a bid in a real-time market because there's a favorable difference in the price there. So predicting the future is a big area that sort of drives a lot of the automated bidding decisions that are made. Speaking of decisions, once you have the inputs, let's say a price forecast, some weather forecasts, all of the associated inputs that you need to make a decision, you need some automated way of actually making that decision. And there's a number of ways you can do it in varying levels of complexity. So the goal overall of an automated bidding system is to maximize the revenue of my site subject to some constraints. And those constraints can be from the market. There's just market rules, market timing, things like that. Some of them may be constraints on my equipment or constraints on my point of interconnect to the grid. There's a lot of things that go into formulating the problem, and basically want to respect those constraints and then operate within them to maximize the expected revenue. There's a lot of different ways to do it. So I could take a simple rule-based approach where, let's say, if my price forecast shows the price is going to be above $100, I bid, this much power for my site, right? That's a very simple approach that is fast to implement. It's fast to execute, but it's low complexity. I've listed a few other ones here. Let's say linear optimization could be an approach you take where you formulate, some what we would call an objective function, where you say the total revenue I expect is basically a sum of a bunch of power times my expected prices over the different trading intervals in the upcoming trading day. And I want to optimize that amount. And I have a bunch of constraints, like I can't drain my battery below a certain amount of charge, right? I can't deliver more power than my point of interconnect. So that's one way to make decisions. Another one that's related but slightly more complex is stochastic optimization, where I do the same sort of thing, but I take a view of what are the uncertainties in these forecasts, and I run a bunch of different scenarios, basically testing what would happen. Let's say if the price forecast deviated from the central value by, up or down by some amount. So you can run a bunch of simulations effectively looking at these different trajectories of what the price could do, what the forecast of the PV could do, and use those to make your decision with some sort of estimate of the probabilities in mind. The last one I'll mention is reinforcement learning. So if you've ever seen, let's say, an AI, agent playing a video game, that's basically reinforcement learning. So you could think of trading in a market as the same sort of thing, where your power plant is a player in the game. The game is the electricity market, and I want to learn how to play the game. And I can do that by practicing over and over again. You can basically train a model to play the game, basically by making trades and learning what works better and what doesn't work better. And so all of these different approaches have different sort of levels of speed and complexity. And that feeds into how some of them might be used in different scenarios, where if I need to make a decision, but it takes a long time to compute the outcome, maybe I can't use that. But in general, these are some of the approaches that are taken in this space for making decisions about trades. So I want to dive into Intellibitter specifically and talk about what Intellibitter offers and uses some of these different approaches to generate bids. So Intellibitter is a software as a service bid optimization platform with the goal of maximizing revenue for some energy storage. It could be standalone energy storage, or it could be storage plus something, let's say solar plus storage. But Intellibitter includes weather and price forecasting. A user can basically define their own strategy and constraints, and that's different from customer to customer. So some customers may have some portfolio where they want to treat one site in a certain way and they want to add custom constraints to that site, or they may have some other contract, let's say a PPA, that they have to work around. So a user can basically use the platform to create their own strategy that suits them and their use case. And then we'll take that strategy and all the constraints and inputs, like the state of charge of the battery, the price forecast, and so on, and use that to generate a set of bids that are optimal for some predetermined look into the future. It could be for a day ahead bid generation. It could be for some real-time bid generation. Depends, different markets have different timing. And then basically the last thing, and we'll talk about this in a bit more detail, is strategy backtests. So once a user has created a strategy, we can run backtests over historic data to see how it would have worked in the past, with some assumptions on how bids would clear in the market, how they would affect the price, and so on. And we'll chat about that in a bit. So that's a high-level overview of the Intellibitter product. I wanted to show just quickly what a typical layout of this system would look like deployed with some site. So this is a high-level view where Intellibitter is sitting in the cloud, connected to some on-site controller. It could be a GEMS controller, could be some other third-party controller, but we have to retrieve information about the site in order to know what's happening and to formulate those bid decisions. So things like the state of charge of a battery, some equipment may be off. We need to know that. There may be maintenance that needs to be scheduled for something. So there's some connection to the site in order to retrieve information about the current status. And then we also interface with some system operator. So let's say in California, that would be CAISO, for example. And then we can retrieve, let's say, price data from CAISO. We can submit bids to CAISO through, let's say, a scheduling coordinator. And then on the left side, once bids are submitted, the site itself is going to interact with the ISO to retrieve, bid instructions, to get, reg signals, things like that, to actually do the dispatch once the bids have been cleared in the market. So I want to talk a bit more about backtesting. So once a user has created a strategy, and that strategy again contains information about constraints on the problem. So things like what markets I might want to participate in. Let's say I only want to do energy arbitrage in the morning. You can create a strategy in here and schedule that strategy to be active in the morning and maybe do something else in the afternoon. Let's say I want to do reg up and reg down in the afternoon. So you can configure a strategy and you can set the constraints, that I need to set. So things like how aggressive should I use the battery? So if I'm doing an arbitrage strategy and I want to chase very small differences in prices, and I'm okay with using a lot of the battery throughput and really driving it hard, I can do that. I can configure my strategy that way. Once you have a strategy, you can set up a backtest, and this is just like a financial backtest in sort of more like stock trading, where I can take some historical set of prices and historical forecasts and treat it like a live, trading situation where I execute the strategy given all those inputs that I would have really had. This isn't connected to a live market. So once I submit the bids in this simulation, I have to act like I'm the market and clear them myself. So we do that with some assumption on how your bids would affect the price. If you're a very small site in a market, you're basically not going to affect the price. If you're a very large site, you may have some price setting capability. So there's a tunable parameter that's a part of this backtest that essentially sets that price elasticity. So the bigger your bids are, the more they would affect the clearing price, essentially. But we can run some simulation over historical time, and then estimate, what it would have produced over that time period. Let's say an estimated revenue, average per day over that time. How many battery cycles would you have gone through? Things like that. And this gives you an idea, it's not a perfect representation of how this would happen in reality, but backwards looking, it gives you an idea of how one strategy would compare to another. Let's say you've run a backtest and you've selected a strategy and you're ready to employ that strategy on the site. Once it's active, you can monitor the performance of the active strategy through Intellibitter. So you can see a few of the KPIs you might track here. So things like the expected revenue over the next 24 hours, the next trading day, with the with the strategy that's currently active. I can see an estimate of the settlement over the last 24 hours. I can see things like with the strategy that's in place, how much throughput do I expect to see in my battery? So something like 2.2 cycles estimated, with the current strategies that I have. You can also estimate from the dispatch information over the previous trading day how much battery throughput that I have. In addition to that, you can track how much revenue did I capture relative to how much was possible. So we can run what we would call like a perfect knowledge benchmark. Once a trading day has ended and you know what all the prices were, you know what all the forecasts were, and so on, you could say, if I knew all of that perfectly in advance, what's the most I could have captured? What's the most revenue I could have generated with this strategy? And then you can compare that to what you actually generated. And that gives you a sense of maybe how much money you're leaving on the table. So that's a really cool feature. This is one of the main, I think one of the main drivers of the Intellibitter platform, this what we call Bid Lab, and the ability to create strategies, test them yourself, and monitor the performance as they're live. I wanted to talk for a couple minutes about solar plus storage. So we've talked about sort of battery throughput, battery usage. Some of the more interesting cases for auto bidding are when you have a battery plus something else. Let's say in this case, battery plus storage. And this example here is in California in the CAISO market, where you have a day-ahead market and a real-time market. And so in this case, let's say I naively had a strategy that I wanted to implement that was, I expect prices to be low in the morning, so I'm going to charge my battery, and then I expect prices to be high, sort of as the sun starts to go down, and I want to discharge my battery then. And so that's I just want to have some simple rule-based approach. Well, that's problematic when it actually turns out not to be as sunny as you thought, because now you don't have enough energy to discharge later in the day. And so this is sort of an example of where an automated bidding strategy can really help readjust, the schedule optimally as you experience that decreased solar production in the morning. So here's an example where there's multiple forecasts, multiple sources of uncertainty, where we would predict the PV, for several days in advance. We'd forecast let's say the energy price, the day-ahead energy price, the real-time energy price. We could forecast ancillary service prices as well, and then generate a strategy operating in whichever markets you choose in order to optimally bid those assets. And then as the day progresses and we experience deviations in the schedule due to differences in, let's say, how sunny it was versus what we thought it would be, we can continually re-optimize throughout the day, let's say in the real-time market. So that's an example where sort of increased complexity from different sources of uncertainty is a ripe opportunity for some approach like this with an automated bidding system. I wanted to segue into something that's a very similar use case, but not in the electricity market. And I just want to spend a couple of minutes talking about that. This is a project that we commissioned last year that is very similar to this hybrid solar plus storage use case, but with a PPA instead of just a wholesale market. But there are a lot of similarities. So this is a site that's a DC coupled solar plus storage site. This is in Georgia. So it's 80 megawatt hours of DC coupled batteries with 260 megawatts of PV. And it's interesting because not every single section of PV has storage coupled to it. There are some standalone PV arrays and then some that are coupled to a battery. And the total interconnect here was just under 200 megawatts. And this site had a PPA that required the customer to commit a full day ahead into how much energy they were going to produce every hour of the following day. And so it's very similar to a wholesale market where you have some basically physically binding bid saying this is how much I'm going to produce, and I'm kind of sticking to that number. And here the problem is basically every hour of the next day I have to do my best to actually achieve that. So this is one case where adding storage can actually help firm up how much energy you're expecting to actually be able to commit to on the following day. And I just want to talk about some of the technology used here. So here, for example, this is very similar to a day ahead bid in a market where in the cloud, in the morning, basically, let's say 5 a.m. in the morning, we will run a process that will generate what's essentially the same as a day ahead bid. So what we call the commitment scheduler in this example, where Jim's Intellibitter is looking at the forecast of the PV generation, looking at its uncertainties, and finding what's the most likely scenario of how much I can actually commit to producing tomorrow without running too much of a risk of not being able to do so. So in the morning, we'll generate that number and we'll send it to the off taker, and they have that schedule in the books for tomorrow. And then there's a secondary process that's basically doing the dispatch of those commitments that we put in the system from the previous day. So once we've committed to generating a certain amount of energy, the success of this, basically the success criteria is how many hours to actually meet that commitment to within some percentage. And so what matters is the overall number of hours that you actually meet your commitment throughout a year. And so we have to make decisions on, sometimes, let's say we thought it was going to be very sunny, it's cloudy. Maybe I don't have enough battery capacity to actually meet that hour, and I should just throw it away. I should just decide it's not worth trying to use all my capacity to meet this 1 hour, because I have the rest of the hours in the day where I can actually use my battery much more effectively. So it's a really complicated problem, and it's a very good example of using technology to solve it in a way that is much more optimal than a human could reasonably do. So we have a dispatch optimization process that will take care of deciding how much battery usage to have at different hours of the day. Basically set a set point for all of the solar, all of the battery units. And this takes into account maintenance windows. It takes into account the variability in the amount of irradiance that the solar park is seeing at different times of the day in different areas. If you have a solar field that's very large, it's acres and acres, some parts will be cloudy and some parts will not be. And so you have to manage that difference in your set points. So we're actually setting individual set points at different locations to basically avoid some batteries being at a much higher or lower SOC than the rest, much higher lower state of charge, that is. So that's just one example. That's a very similar thing that maybe not a lot of people have thought about, these complex PPA cases where it's basically the same as a bidding situation. But you can do this in a PPA when those types of situations are required. So that's the gist of the presentation. I'll pause here and we can take a look at some questions, Christina.
Perfect. Well, thank you so much, Jason, for this presentation. It was really interesting, a lot of new things, at least for me. And we do have tons of questions coming, so we're not going to have enough time, but we'll send them your way. So as I said, I do have a couple of questions, and then we'll move on to the ones that some participants have. So the first one is that you were talking in the beginning about strategies. So what are the best auto bidding strategies for you? What ones would you recommend from your experience?
Yeah. So I think as a lot of things do, it depends, right? It depends on the customer. It depends on the market. Like different markets have different rules. So it's difficult to really say like one particular strategy is the best, because every customer is different, every market is different. But I think there are like general principles when using an automated bidding system that apply that will lead to success. So those include things like the ability to run simulations on a strategy, right? If I have a strategy, I want to be able to benchmark its performance. Things like being able to audit bid decisions. These are parts of a bidding system that you want to have in place, right? So if there's some decision that's made that I don't understand, if I can go back and look at maybe what were the inputs at that time and verify if it makes sense or not to me, that auditability is a key feature. And sort of similar to that, having a human in the loop can be important, especially as, let's say, a customer is bringing in a system like this and it's brand new, let's say to their trading team, they're trying to augment their trading team. Having that trading expertise and being able to look at those decisions, being able to, let's say, produce some bid generation and have someone approve it or have the ability to at least review it. Those are things that I would say broadly apply, to what makes a successful sort of strategy.
Perfect. Well, thank you. It absolutely depends. A lot of factors coming in. I have another question that also appears in our Q&A from Aitor Santo, which is what might occur if a large number of clients use this auto-bidding system at the same time? Are there any issues or what exactly happens?
Yeah, it's an interesting question. So, let's say a large fraction of, let's say the storage, sites in a market are using the exact same, automatic bidding system, right? So in that case, I could think of some issues that may arise. Let's say everyone is using the exact same price forecast, and everyone's making decisions, let's say to charge or discharge at the same time because of that. It could lead to some sort of price setting behavior where let's say there's a lot of storage in the market, and they're all bidding at the same level. That could, let's say, raise prices or at least cause a lot of price setting behavior, and everyone's going to basically be at the same level. It could end up raising the prices. So those are the types of things that I could maybe think happening. I think that scenario is a bit unlikely, even if everyone is using the same system, though, because customers have different constraints. They have different asset mixes. Let's say they have everyone has solar plus storage, but they have different ratios of solar to storage, or they have different interconnect limits, or they manage the SOC different. Not everyone's battery is going to be full at the same time. So I think some of those factors would prevent everyone from bidding exactly the same, if they're all using the same system. So those are a few thoughts about what would happen.
So it would be a major coincidence if everything would be the same.
I think so.
Right. What is the role that AI is playing in auto bidding for you right now? And what do you expect to see in the following 5 to 10 years?
So AI, really comes into play for sort of the two things I had mentioned about predicting the future and decision making, right? So sort of, let's say, machine learning based techniques for time series forecasting, right? That's a sort of a role where AI plays a major part. Also decision making techniques. Some of them could be machine learning, some of them are not, let's say, learning necessarily, but they still fall into the general realm of AI. So let's say some system that's making decisions, you could call that AI. It could be machine learning, let's say in the case of reinforcement learning, where you can actually train a model with a bunch of history and have it learn what bids are successful in different situations and which aren't. So those are the areas where AI really come into play. I think over the next 5 to 10 years, the major changes or improvements would come in using more sophisticated models in these different areas. So let's say for price forecasting, for example, you could even have a lot more data that's relevant for training a model. So we could have more data on transmission, right? Like, let's say you have a full power net flow diagram, like an ISO would basically solve to generate the price. There's a lot of detail there that maybe the average player in the market doesn't have. Maybe some of those things will become more widely available, and that will provide more rich data to train these kind of models, and you can have more complexity sort of in where AI comes in. So I think that those are the types of things that we'll see related to AI in the next few years.
Perfect. Thank you. Another question is, are there other use cases of energy storage that leverage the same technology?
So I think there's a long history of using optimization techniques in the energy industry, just in general. But as far as energy storage goes, we talked about bidding in a market. We touched on using similar techniques for a PPA, for optimizing participation in some PPA. There are other cases, let's say in my experience, working on like microgrids is one place where it's very similar situation where you have to schedule a plan of what each asset is going to do over some horizon. And that involves forecasting. Let's say you have an electrical island and you're controlling the entire island, forecasting the load, forecasting how windy it's going to be or how sunny it's going to be, and then making decisions about, when I can charge my batteries, when I can discharge them, when I should curtail, when I should turn engines on and off. Those are all very similar, problems that involve similar kinds of technologies to solve.
Perfect. Thank you. Moving on to questions from participants. The first one is from Elias. He asked if does the auto bidding optimization take into account the cost of battery life deterioration?
Yes. So basically the way that we handle that is we provide a parameter that you can dial up and down to control the throughput of a battery, right? So I mentioned, let's say you had some sort of arbitrage strategy, and I just want to be very aggressive with my charging and discharging, right? I can make it much cheaper to use the battery in this optimization problem. Let's say I don't want to do that, and I want to be very conservative with my battery. I can dial that cost up and make it more expensive to use the battery. So we do have cost parameters, I would call them. And then I think by using something like a back test or simulation framework, you can see, given the prices, if I use the strategy, how much throughput would I have, and that can help you dial tune those parameters. But at the end of the day, depending on sort of the investment, like the CapEx cost and what the operator's outlook is on the prices, they may be okay with running the battery very hard and getting their payback in a small number of years, and then needing to augment the battery or just replace it. So those are some considerations for sure.
Okay, great. Well, thank you. Next question is from Jamie Marcos. He asks, can the software adjust for a change such as sudden loss of a transmission line or loss of generation that causes services or energy income to spike?
So basically changes to sort of the network, maybe outside of my site, essentially, right? Like changes to transmission. So I think if you had some situation like that where there's a transmission line down or a site goes offline, elsewhere in the grid, like the result would be maybe an increased price. Like there's let's say less generation and the same demand, so there's more price, the price is going to go higher, like the clearing price. So that's an example of sort of one of the advantages I mentioned, reacting to these kind of quick changing conditions. So let's say I had a situation like that, and I see the price is going to be higher. Maybe I see it's going to be higher for several intervals into the future. Let's say the next hour, right? My price forecast will adjust. That's a case where an automated decision-making process can see those changes happening. They'll be reflected in the price, and I'll respond accordingly. Let's say I'll wait. Let's say I expect the price is going to be even higher because of this, prolonged transmission issue. I may wait and then choose to discharge my battery in an hour into that event when I think it's going to be the highest price. For sure, those are things that I think forecasting and scheduling really help in those situations.
Okay, thank you. Next question from Martin Homek. Yes, if your product is being used anywhere else right now. And then he moves on to local building permit required. I think this depends a lot on locally where you're based. But he also continues saying, is a state program requiring approval for environmental and operation certainty required? And does it involve electric or other transportation regulated by the Federal Energy Regulatory Commission? Mm-hmm. I can repeat that if you want. This is a lot of information.
I'll take a stab at it. Yeah. So,
okay.
Yeah, I think as far as where kind of our main geographic focus areas, I would say
Yeah.
Like California, the CAISO markets is a major area of activity. Australia is another one. Those would probably be the two biggest areas that we have activity in. And then as far as sort of regulatory issues, I think regarding like automatic bidding systems, like the deployment of Intellibitter type of product, there's not really sort of regulatory issue with that. The customers, is free to operate the site how they want. I think if I understood correctly, those apply much more to actually the construction of the site itself, right? Getting approval, getting in the queue for some interconnection agreement, right? Those are the kinds of things where like you have to go through some regulatory process, and it takes more time. So hopefully that makes sense. Let me know if I need to maybe address any other parts of the question.
I think it does. If not, just let us know in the Q&A section. In the meantime, let's move to another question. Wilfer Arango asks if you have any experience integrating hydrogen production, or are there any pilots available, even though it's a very new technology right now?
I don't have any experience. I mean, Wartsila more broadly, we have an energy division that includes research on hydrogen-based fuels and so on, sort of more in the energy in the engine business. But I personally don't know that much about sort of hydrogen research. Okay,
well, thank you very much. However, we'll send this on Wärtsilä's way if they want to respond as well, that specific department. Then we have a question from Jamie that Marcos that asks if the software considers pricing at node level or other.
Yeah, so at node level. So because typically a price will have several components. One of them is kind of a regional level, right? Like some big region has a regional energy price, and then nodes within that region have adjustments or corrections to it due to like transmission or congestion constraints. Let's say there's a lot of production in one area that's going to affect the price. So we would look at like nodal price forecast. That's the most relevant, because a lot of times if there's price spikes, it's due to those local phenomena, not necessarily a spike across a whole region.
Okay, well, thank you very much. We are almost out of time, but thank you for everyone for all those questions. Just to finish up, Jason, I don't know if you have any final remarks to end this session.
Yeah, I just thank everyone again for paying attention and listening in. I think this is an area that is early. I think as the rollout of a lot more storage technology comes into play in different markets across the world, this type of solution will become more and more important, especially as companies build larger and larger portfolios of sites, managing them all effectively. This is certainly something worth exploring. So yeah, feel free to reach out to me or look at storage.wartsila.com for more information.
Okay, well, Jason, thank you so much for your time and a great presentation. It's been really interesting, and we look forward to have you at one of our webinars more. And thank you everyone for joining us today's session for our RedMed Storage USA event that will be taking place on the 18th and 19th of April in Las Vegas. Hopefully we will see you there. And if you have any questions, just let us know. We hope to see everyone soon in our further webinars that we have. And we will be sending the recording in a couple of days. So thank you, everyone, and have a great day. Thank you.